Okay, this is where we left off. Patricia, can you read this one?
Yeah. Decorators. Decorators provide a way to modify functions using other functions. This is ideal when you need to extend the functionality of functions that you don't want to modify. We defined a function named decor that has a single parameter func. Inside decor, we defined a nested function named wrap. The wrap function will print a string, then call func and print another string. The decor function returns the wrap function as its result. We could say that the variable decorated is a decorated version of print text. It's print text plus something. In fact, if we wrote a useful decorator, we might want to replace print text with the decorated version altogether. So we always got our plus something version of print text. This is done by reassigning the variable that contains our function. Now print text corresponds to our decorated version.
Okay. So we run that and we see it prints hello world inside those. Just putting the what's it called? Passing the text. I mean, you could really call this print text. Call this print text. And or no, sorry, because you're passing this function that does print text into this, so you're having this do that. So I guess you do kind of, you would call it a function because you're calling this function print text and you're passing this function print text in there and then calling it within the other function, this one. And then you're returning this. But any questions on that? I know that's kind of confusing.
I think it makes sense what it does. I don't understand at all what we would use this for.
Yeah, I don't really use this. But anyway, good. Glad you understand it. So as long as you understand it, that's good. Okay, go ahead, answer the next question. Well, no, I guess that's not true. Sometimes I use functions in other functions. Just to, I mean, not like this where it just wraps it. But like if you want to do something multiple times inside a function that you've already built, instead of like it's the same thing as like why you do functions. So it's code reuse. It's so that you can reuse code without having to write it multiple times. And sometimes in functions that you have doing stuff, you want to use other functions so that you don't have to write it multiple times. Does that make sense? So
Yeah, that helps.
Is that more like robotics where you're like left turn, right turn, up, down? But instead of writing the whole string of code, you're just giving it simple command that it's referencing to?
yeah. Yeah, I mean that's a good example. But I mean, but that's just functions in general. Like like that's what you would use functions for. This is more using a function inside a function. So the example you're talking about would be more like you have a function maybe called like scan or something that like moves forward and detects blue objects or something, right? And then once it reaches that blue object, then it calls your other function inside that function, and then does its little spin or whatever, turns, or
Pickup object or
whatever you
whatever.
want it-
Yeah.
yeah, whatever you want it to do. It's just functions and functions.
Yeah.
Yeah, so what are decorators? Functions that modify other functions. Mike, can you read this one?
Decorators. In our previous example, we decorated our function by replacing the variable containing the function with a wrapped version. This pattern can be used at any time to wrap any function. Python provides support to wrap a function in a decorator by prepending the function definition with a decorator name and the @ symbol. If we are defining a function, we can decorate it with the @ symbol as shown. This will still have the same result as the above code, and a single function could have multiple decorators.
You will see decorators, well, not a lot, but you'll definitely see them used in other people's code. So it's definitely good to understand what they do. But like, okay, so first we'll look at this one, right? It's the one we did before where it just does hello world. But now if we look at this one, so we've created this function that uses the function. All right, hold on. I got an idea. Let's print them back to back so you can see both at the same time. So here's our original one, right? And we did print text, and then we did print text equals the decor one that we had already defined, just like up here, we're already defining it, and then passing in print text, which we already defined. Well, instead, we're just doing, on this one, we're defining decor and then saying, okay, decor is going to be used with print text. So then when we just do print text, it already knows it's going to pass in decor. Does that make sense? So this is just a different way of writing this. You're just, instead of adding this part right here where decor you pass in print text, you're saying decor pass in print text that I'm defining right here. So any questions on that? Because I want y'all to understand that in case y'all ever see this. Okay. Okay, go ahead and start on the practice and raise your hand once you're done. Hey, I'll give y'all a hint on this one. Um, don't forget in your wrapper text, I get that it returns the def there, but you've got another def inside that def, so you're gonna need to return that for it to be able to work. So you're gonna have two returns there.
Hey, Brendan, I don't know what I'm doing wrong on this one.
Okay, you want to do screen share? Go ahead and expand the wrong answer thing. Well, it's saying, hold on. So you're on line 11, you put it in quotes. You just want to pass actual text, not the word text. So just get rid of those quotes because you're passing the variable, not a string of text. Okay, now hit run. And there you go. Okay. Anybody else struggling with this one need some help? Nope. Okay. Then moving on. Okay, which statement can be used to achieve the same behavior as my func equals my func, and then my des, and then pass in my func, my des. David, can you read this one?
Recursion. Recursion is a very important concept in functional programming. The fundamental part of recursion is self-reference. Self-reference functions calling themselves. It is used to solve problems that can be broken up into easier subproblems of the same type. A classic example of a function that is implemented recursively is a functional function or factorial function, which finds the product of all positive integers below a specified number. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, or 120. To implement this recursively, notice that 5 equals 5 times 4, 4 exclamation equals 4 times 3, exclamation 3 exclamation equals 3 times 2 exclamation, and so on. Generally, n exclamation equals n times n minus 1 parentheses exclamation. Furthermore, 1 exclamation equals 1. This is known as the base case, as it can be calculated without performing any more factorials. Below is a recursive implementation of the factorial function. The base case acts as the exit condition of the recursion.
So, long story short, recursion is using a function within itself. And so you get 120 because, all right, so the base case, like it's talking about, is this is what's gonna stop it once it finally stops returning itself, right? So instead of like, in this case, it's kind of like x minus equals 1, right? So x is times um uh well Anyway, it's just using itself, so it ends up doing five. First X is 5, then it's 4, then 3, then 2, then 1, right? So it's just reducing it by 1, and once it gets to 1, then it stops. Does that make sense, or is anybody unclear on that? Okay. So go ahead and answer the next question. Okay, so what is the base case of a recursive function? A case that doesn't involve any further calls to that function. So the thing that ends the recursion. Jacob, can you read this one? Jacob,
Yes.
could you read this one?
Uh, recursive function can be infinite, just like infinite full loops. These often occur when you forget to implement the base case. Below is an incorrect version of the factorial function. It has no base case, so it runs until the interpreter runs out of memory and crashes. Run the code and see how it works.
Long story, we're not gonna run it because long story short, don't do this. Always add your base case so that you don't create an infinite loop. It's just like not adding x plus equals 1 to a while loop. All right, go ahead, answer the next question.
What would be the base case?
Well, it would be the one before it, so it would be, this would be the base case. So this is what they put. They put this with, all they put was the return factorial x1. But if you had your if else statement with this part right here, that would be the base case that eventually it's going to reach that and not return, not call on itself again. Does that make sense?
Yes.
Okay. Okay, what is the result of this code? You get a runtime error because there's no base case, just the infinite loop.
Can you say one more time what you mean by base case?
Yeah, so the base case is the part in the function that it'll eventually reach that doesn't call itself. So like, okay, so this one, right, is odd, right? We've got, okay, well, actually, this is odd one's a bad example because this one won't work. So we'll do the is even because this has a base case, right? This, you see where my mouse is going, right?
Yeah, I'm watching it.
Yeah, this part is the base case because, so first so we pass in 23, right? And so x is 23. Well, x is not equal to 0, so it's going to do the else, right? And then but then the else returns it calling, well, actually this one is calling us. Okay, let me go back to the other one. Okay, this one's a better example. Okay, so they pass in 5, x is 5. Okay, well, x is not equal to 1, so it does the else, calls itself, it returns x times the calling itself and x minus 1. So first we have x, and then so now x is going to be 4, right? So then it was 5 times the next the 5 times and then 4 and then 4 then becomes 3. So it's doing this right here. 5 times 4 times 3 times 2 times 1. And once it equals 1, then it stops because it eventually got to where
It meets that objective.
right. And so the base case ends the loop.
So in the paragraph above this example, it talks about the 5, 4, 3, 2, 1. What is the 120 in parentheses?
That's the answer. If you multiply 5 times 4 times 3 times
Oh, okay.
times 1. Yeah.
Got it. Okay. All right. Thank you. I thought I was supposed to understand some part of the expression there. I didn't really get what that was.
Oh yeah, no, they're just telling you the answer of when you multiply all those that way. So
Got it. All right. Thank you.
uh-huh. Okay. Did we read this one? No, I don't think we did. Will, can you read this one?
Sure can. Let's see. Excursions can be indirected. One of the functions can call a second, which calls the first, which calls the second, and so on. This can occur with any number of functions. Example, run the code and see how it works. Let's see.
So
Change it. Go ahead.
oh yeah, you don't need to read that. It's all good. So I was wrong earlier. I didn't really look at it or see what it was talking about. But with this, so this one is not not going to be an infinite loop because it's calling on this one that does have a base case. And so they're going to go back and forth, but eventually it's going to equal 0 and have the base case and stop both of them. So, all right, go ahead, work on this and raise your hand once you're done. Okay, seems like a lot of you are done. Tim, can you go ahead and share screen and share your answer, please?
Yes. Hold on. I minimized it by mistake. I got you right now. All right. Pretty much, it was said right here, the two exponentials, two multiplications. I asked this earlier, and it was exponential. So I seen over here, the 0 and the brackets, exponential 2, and that's it. That's all that had to be entered in this equation, and then ran it.
Good. All right. Good stuff. And moving on. Oh, is anybody stuck on that one or need any help?
I guess I have a question. Mine is a little different. It definitely has more, I guess, code in it or
Okay,
more.
can you do screen share?
Yeah. I just want to know if that's acceptable or if I have to make sure that I
Get the
memorize.
right answer?
Yeah.
Well, then
Actually,
that's all that matters. There's 100 ways to skin a cat, but let's see your way.
okay. Here.
Uh-huh.
Brandon lives around a lot of dead cats.
I did it individually here.
Yeah, I mean that works. So yeah, it's all good. Either way it gets the same result. So
Okay, but this won't be frowned upon this way, right? Or should I like try to stick to the other way? Like try to memorize that way?
no, output is all that matters at the end of the day. Okay, that's not entirely true. Technically it's output and performance.
Mm-hmm.
But like performance is mostly an issue if like you're dealing with like game design and stuff and you're wanting your game to run faster or use up less memory or whatever for like web-based programming and stuff. Like the calculations are so small that it's like it's not even
Mm-hmm.
it's not even really going to affect it. Um so yeah, long story short, if you get the right output, then that's all that matters. So
Cool.
yeah.
Thank you.
All right, Brandon.
Uh-huh.
So based on what Patricia said, yeah, I want to ask you a question on that because not knowing the world of programming. Okay, so in this case, with Patricia's code, would that be considered, or what would be the definition of a clean code based on how she wrote it compared to the other one? What is clean code? I mean, when programmers are talking about clean code, what are they talking about?
Just like not extra extra stuff that either one bogs down like extra memory or is not very efficient, and like you put a lot of like extra stuff in there or like not using like doing copy and paste as opposed to using functions, stuff like that. Does that answer your question?
Oh, okay. So copy and paste. Okay. You mean code wise, not like copy and paste from a source and then pasting it on.
Oh yeah, no, you can take it from sources, but when I say copy and paste, like here, I'll show you what I mean. So here's an example. Where would that be saved? Documents, I think. Hold on. No, it is. It's this one. So I was bored and I was on Stack Overflow. And somebody asked a question for how to make code more efficient. And they had like a million. Here, actually, I'll show you their code. Hold on. Oh my gosh, it's taking forever. Let me switch to. Let's eventually load.
Taking this time to load. Let's see.
Yeah. There we go. This one. Hold on.
I was taking on.
Removed it because they shut the question down because I guess you're not supposed to. That one. There's another one I answered. Anyway, it doesn't matter. Wait, here we go. This one. This one. No, that was a different one. Yeah, I think they took it down because you weren't supposed to just ask how to make code shorter because it was listed as closed. But anyway, the guy had like 20 or 30 like elif statements to accomplish this, right?
Right.
He was like, if this is bigger than this, then if this is bigger than this, and so that was like not very efficient, right? And I just did it this way by like I showed him a better way to do it by saying doing a definition for which is bigger, and then calling that twice, and then doing this to see which is smaller or whatever, right? And then combine the sum, like taking the leftovers and put them into a thing and then comparing those there. But anyway, so that's like more efficient than his like 30 lines of
So it sounds like something that, for me to understand in my own words, something that's like redundant. Like it doesn't need to be there. It's like extra stuff for no reason.
yeah,
It's that something like
we're doing it like a longer way that's not as efficient and stuff, or just like you're adding more code than you need to, you know what I mean? Oh, and what I was saying about the copy and paste, which is why I pulled this up, is because what's it called? Instead of doing a definition, right, I could have just done if if throw one is greater than throw to. And like, and then I could have, you know, copied and pasted it and done the same thing, as opposed to, and then changed it to the other one to comparing, you know, smaller 0 to smaller 1, right? But instead of doing that and copying and pasting, I just did a definition and then called it twice, which is more efficient, like less lines of code and not having to use copy and paste. You know what I mean? So
Yes.
yeah. So that's kind of what like cleaner code is just like better looking, more efficient.
Wouldn't that come with just time anyways?
Yeah.
Yeah. Okay, I see. So as long as it gets the job done, straight to the point. I know Patricia did hers a different way, but it's still, since it still met it still got a job done. That's fine in that case.
Yeah. Yeah. So it gets along, like the other guy's code worked, the one with the 30 elifs, and it got the job done. But like mine is just a little bit cleaner. You know what I mean? So you
Right.
you can have dirty code when you're a beginner. It doesn't matter, especially when you're just dealing with like web-based stuff and you're not, like I said, when you're not dealing with game development, because, or like CPU stuff, or like dealing with OS operating systems or whatever, where like you need to like, you're like clocking your processor and stuff and trying to get it to run faster and more efficient and stuff like that, then it really comes into being important. But with just a web server, it's fine, because it's still going to process it like instantaneously, no matter how dirty your code is, because it's not like running a big graphics processor or something. So
Got it.
yeah. So this one, what's the result of this code? It's 5 because it takes it minus equals, calls itself plus itself minus equals, and eventually gets to 5. So I think we got time for one more. Roger, can you read this one?
Sets are data structures similar to lists or dictionaries. They are created using curly braces or the set function. They share some functionality with lists, such as the use of in to check whether they contain a particular item. To create an empty set, you must use set parentheses as set curly brackets creates an empty dictionary.
Okay, so as you can see, the difference between set and a dictionary is it's more like a list, as opposed to having a key and a value, having 2. So that's the difference if you're manually building it. But like it said, if you're wanting to build an empty one, then you need to do it as set. But most times just using a list is fine. You're not really going to need to use set. But anyway, go ahead and read or answer the next question. What's the output of this code? 1, because if E not in letters print 1. Well, it's not in the letters, so it's going to print 1. Mark, can you read this one?
Give me 1 second. I'm going up to my daughter's school real quick.
Oh, okay, never mind. Kevin, can you read this one?
Yep. Sets differ from lists in several ways, but share several list operations such as len. They are unordered, which means that they can't be indexed. They cannot contain duplicate elements. Due to the way they're stored, it's faster to check whether an item is part of a set rather than part of a list. Instead of using append to add to a set, use add. And the method remove removes a specific element from a set. Pop removes an arbitrary element. Basic uses of sets include membership testing and the elimination of duplicate entries.
Yeah, so that's kind of what it breaks down to. If you want a list to not have duplicates, then maybe use a set instead of having to check it for duplicates. Oh, darn. Oh, well. Fill in the blanks to create a set and add the letter Z to it. So we do that and then add Z. And then you want to print the length, len, nums. Okay, Patricia, can you read this one?
Okay, just have to go back to mine. Sets. Sets can be combined using mathematical operations. The union operator, I guess I, combines two sets to
Oh,
form.
that's not I, that's so like below your delete or your backspace key, you hold
Yeah.
shift, it's that long line thingy. That's what that is.
Okay. The union operator and that weird thingy combines two sets to form a new one containing items in either. The intersection operator and gets items only in both. The difference operator negative gets items in the first set but not in the second. The symmetric difference operator, sign pointing upwards, gets items in either set but not both. Run the code and see how it works. And then commonality. Given two sets, find and output all elements that are common to both sets.
Okay, and so that one, remember the and gets both. But anyway, I think it's pretty straightforward, but you can see, you know, what it does, combining it, only getting what's in both, and all the other stuff. So the difference and symmetric difference. So go ahead, start this and raise your hand once you're done. Oh, and don't use C solution. If you're having trouble, just ask for help. All right. Looks like a lot of you are done. So moving on. Like I was saying, oh, let me go back. Hold on. So with this one, if you use the and, you're going to get the answer for both. So if you print set 1 and set 2, you're good to go. Yeah, any questions on that one or anybody need help?
I know what in the world I did over here. I thought I was supposed to use unpacking operator.
Say that again. I couldn't understand you.
I said I don't know what I did over here. I did mine differently, but I thought the unpack the operator. Was it the unpacking operator? You did and I did that multiplication there. That yeah, let me show you. Let me show you how I did
Yeah,
mine.
do screen share. Oh, yeah. No, you just gotta, so just get rid of line 6 and then just do set 1 and set 2. So get rid of that multiplication.
I couldn't use that. The end. So the end is just printing 1 and 2.
Yeah, and makes a set that's a combination of the other set that's like right after it, so that it just combines it. So all right.
Okay, let's see.
You're
All
welcome.
right, thank you.
Okay, so moving on. I think we were at the end. Oh wait. There we go. So what's the output of this code? Print A and B. Well, the only common number that they both have is 3, so it's just going to print set of 3. Mike, can you read this one?
Data structures. As we've seen in the previous lessons, Python supports the following data structures: lists, dictionaries, tuples, and sets. When to use a dictionary: when you need a logical association between a key value pair, when you need to fast look up your data based on a custom key, when your data is being constantly modified, and remember, dictionaries are mutable. When to use the other types: use list if you have a collection of data that does not need random access. Try to choose list when you need a simple iterable collection that is modified frequently. Use a set if you need uniqueness for the elements, and use tuples when your data cannot change. Many times a tuple is used in combination with a dictionary. For example, a tuple might represent a key because it's immutable.
Okay. So which of the following data types does not allow duplicate values? Sets. All right, that's a good place to stop. So I will be right back.